Hello, welcome, and thank you for joining us at today's media briefing. I'm Katherine Roloff, NASA's press secretary for the Science Mission Directorate. We'll be recording on Teams, streaming audio on nasa.gov/NASA Live. Right now, millions of Americans are experiencing the effects of extreme weather. There are wildfires raging across North America, flooding in the Northeast, heat waves across the Southwest, wildfire smoke here in our nation's capital, and a record hot June. And NASA is tracking it all. We are here today with NASA leadership, including climate experts, to discuss how NASA provides detailed climate data and research to the world through from space, sky, sea, and land to enable climate solutions. To talk more about our climate work in the wake of record high temperatures, are NASA Administrator Bill Nelson, Kate Kelvin, NASA Chief Scientist and Senior Climate Advisor, Karen St. Germain, Director of NASA's Earth Science Division, Gavin Schmidt, Director of NASA's Goddard Institute for Space Studies, Carlos Del Castillo, Chief of the Ocean Ecology Laboratory at NASA Goddard Space Flight Center, Wee Tran, Aeronautics Director at NASA's Ames Research Center, and Tom Wagner, Associate Director for NASA's Earth Action. We will begin with opening remarks from our speakers, and then we'll open it up for questions. To ensure as many people as possible get the opportunity to ask a question, we ask that there be just one question per person. And do please state your name, affiliation, and to whom your question is directed to. Now, let's hear from NASA Administrator Bill Nelson.
Hey, everybody. I don't need to chronicle what's happening around the country, around the world. The fact is the Earth is heating up. Just look at the record temperatures that are going around the country on the nightly news. But you can see it in ways like why has Miami Beach had to spend millions of dollars on pumps to pump out the water during mean high tide that sloshes over the curbs? The ocean is heating up and the seas are rising. And we could go on and on. We want you to be able to ask the questions that you need to ask today. But let me just point out, you think of NASA as a space agency, you think of NASA as an aeronautical research agency. NASA is also a climate agency. We've got 25 satellites up there that are bringing real-time data. That next week on our new website at nasa.gov, you're going to be able to go and pull up the hyperwall that we have in the east lobby of this building that has real-time what is happening. I said real-time. Only the time that it takes because the asset is revolving about the Earth every 90 minutes to convey that information to Earth of what is happening to currents, to weather currents, to all of the data, the ocean temperatures, the land temperatures, et cetera, et cetera. So we want you to know that you've got a research asset right here at NASA that you can use. Now, we have an instrument called EcoStress. It's on the International Space Station, and it measures the subtle changes in temperature to identify plant stress. And it can be used to identify extreme heat in urban areas. I went to Kansas a while ago to visit with farmers. We can tell the farmer the moisture content of his soil, or we can tell him the disease in his crops. We can tell a forest the disease in the crops which is a heads up for the forest fire that's coming. This data from EcoStress has been employed to reduce heat absorbed in Los Angeles by the city surfaces, such as the asphalt. And in partnership with that city and county, NASA used EcoStress, the data, to implement the Cool Neighborhood program. It's a thermal resistant paint that was applied to select streets in Los Angeles. This pilot project found that a thin gray coating made an asphalt runway reflect the sun like a concrete roadway, making the surrounding areas cooler. So these are some of the examples. In recent months, we've launched a series of satellite missions, SWOT, S-W-O-T, to study surface water, and that's in partnership with the French Space Agency. TEMPO, to study air pollution in collaboration with South Korea and the European Space Agency and Canada. EMIT, to study mineral dust, and lo and behold, to study all that dust, we suddenly found out that we had another thing that it was telling us. It was telling us where methane was being emitted around the globe. Methane is one of the two big greenhouse gases that go up in the atmosphere and trap the heat in. And then another satellite mission called Tropics to study tropical cyclones and hurricanes. And I mentioned the Earth Information Center that is going to be available to you real time on nasa.gov. So do you want me to turn it to Kate now?
Yes.
Okay, Kate Calvin, our Chief Scientist and Climate Advisor at NASA.
Thank you, sir. So recently we've seen extreme events around the world. In the US, we're seeing heat waves, flooding, we're seeing air quality issues due to smoke from wildfires in Canada. They're all impacting people where we live and around the world. This June was the hottest June on record, according to NASA analysis, and you'll hear more about that later today. But what we know from science is that human activity, and principally greenhouse gas emissions, are unequivocally causing the warming that we're seeing on our planet. And this is impacting people and ecosystems around the world. At NASA, we provide end-to-end research about climate, from observations to models and applications to technology. So we can provide information on the changes in climate that we're seeing. We can provide information about the drivers of those changes, like greenhouse gas emissions, and the impacts of climate change. We also develop technologies that can help us mitigate or adapt to climate. Just as one concrete example, for wildfire, our observations can show us where fires are burning. They can show burn scars and burn perimeters. We can provide information about emissions from fire, which can lead to air quality concerns. And we're also working on using NASA aeronautics technology to help respond to fire. And you'll hear more about that as well today. Everything we do, we work on providing information to people so they can make informed decisions. So providing both the data from our satellites and models, as well as tools and resources to help people use that. In June, as the administrator mentioned, we opened an Earth Information Center with both a physical space that's here in Washington, D.C. in our headquarters lobby, as well as a virtual space for those that can't come to D.C. Because whether people are living in cities or in rural communities or in suburbs, we're making decisions every day that are influenced by climate. Everything from a home buyer assessing flood risk to a farmer thinking about what to plant or when to water their crops. And what we want to do is make sure that the information we have about our planet is available to people so they can make those decisions better. And so the Earth Information Center will allow users to see the planet and how it's changing, and provide easy to use information to support decision making as they respond to climate change. And with that, I'll turn it back.
Thank you, Kate. Next will be Karen St. Germain, Director of NASA's Earth Science Division.
Thank you so much. And I'll talk about three main points here. First is the observations, and Administrator Nelson mentioned these briefly. NASA operates a fleet of missions to study the Earth as a system, the land, the ice, the atmosphere, and the oceans, and to see how changes in one drive change in others. Today, we're operating over 24 missions studying our planet, and these observations reveal changes in extreme events and the impacts of climate change. In recent months, we launched the 4 missions that Administrator Nelson mentioned: SWOT, TEMPO, EMIT, and TROPICS. And we have a couple of upcoming missions, such as PACE and NISAR, which will provide even greater clarity and understanding of how the warming climate is driving change in biological systems, or what grows where. That's the first key point, is the foundation is all of these observations. Second key point, this wide diversity of observations sustained over time has taught us actually much of what we understand about how and why the Earth system, including climate, is changing. The study of climate is the study of carbon cycle and ecosystems, atmospheric composition, water and energy cycle, climate variability and change, weather, and atmospheric dynamics. In other words, there's a lot to understand here. And while climate is not just long-term weather, most of us will experience climate change through severe weather, which we've seen recently with drought and heat in the Southwest, flooding in Vermont, and the atmospheric rivers in California earlier this year. At NASA, we capture the scientific understanding that we get from these observations in highly sophisticated data-driven models that then allow us to predict into the future. And Gavin is going to talk to you more in a few minutes about that. Third key point, our science isn't done until we've communicated it. And this has never been more important or compelling than it is today. NASA Earth Science's end-to-end capability, from technology all the way through what the observations mean today and into the future, that end-to-end capability allows us the opportunity to deliver actionable science and information so more people can see the Earth as we see it. Our Earth Science to Action strategy seeks to accelerate scientific discovery and the use of Earth science by leveraging that end-to-end capability for the benefit of humanity. Informing decisions ranging from a farmer assessing what to do with a single field to global leaders weighing decisions impacting the entire world. So our goal is to put scientific information and understanding out in ways that help the public. We do this by supporting a dozen other federal agencies. For example, we support FEMA in responding to extreme events, and USDA's Drought Monitor. We develop easy-to-use tools to address decision-maker needs at the state, local, and tribal level, like providing information to support fire managers in anticipating, responding to, and recovering from wildfires. And then finally, making that information easily accessible through platforms like the Earth Information Center and online, so that all of our citizens can be informed. And Tom is going to tell you more about that in a little bit. Thank you.
Thank you, Karen. Next, we have Gavin Schmidt, Director of NASA's Goddard Institute for Space Studies. Gavin?
Thank you very much. We are seeing unprecedented changes all over the world. The heat waves that we're seeing in the US, in Europe, in China, and demolishing records left, right, and center. This is not a surprise. We have been tracking the changes in temperature over time since the 1980s, when we first started to put together global estimates of how temperatures are changing. Those records go back to the late 19th century, and we can see that there has been a decade on decade increase in temperatures throughout the last 4 decades. This last June was the warmest June on record, and we anticipate, with the understanding of what's going on a day-by-day basis, that July is likely to be the warmest absolute month on record in that record, and that's going to be a record that effectively goes back many hundreds, if not thousands, of years. We don't see this every year. The last time that we saw this was in July and August of 2016, when we were coming off a super El Nino event in the winter of 2015-2016. We haven't got there with the current El Nino event. So as many of you know, we have an El Nino event that is emerging in the tropical Pacific, but it's really only just emerged. And so what we're seeing now is not really due to that El Nino, though it is playing a small part in the global mean change. But what we're seeing is the overall warmth pretty much everywhere, particularly in the oceans. We've been seeing record-breaking sea surface temperatures even outside of the tropics for many months now. And we will anticipate that is going to continue. And the reason why we think that's going to continue is because we continue to put greenhouse gases into the atmosphere. And until we stop doing that, temperatures will keep on rising, and the temperatures that we see on a monthly basis, they're going to be reflected in the daily data. Now, the daily data that everybody's been looking at recently comes from reanalyses that ingest an enormous amount of both in situ and satellite data from NASA satellites, but also from European satellites and Japanese satellites. That put that together inside a model and then, fill out in a physically consistent way what's happening. Now, each different reanalysis system is a little bit different. They use different data. They have different codes, and so the coherence between each individual reanalysis system on a day-by-day basis is probably not that high, but the overall pattern that we're seeing of tremendous heat in the oceans, particularly in the North Atlantic, tremendous heat in the global mean that's really knocking out of the park the previous records, those things are going to be robust, and they will be reflected in the more standard global temperature statistics that NASA and NOAA and the Hadley Centre in the UK release on a monthly and then annual basis. What's happening now is certainly increasing the chances that 2023 will be the warmest year on record. My calculations suggest that that's right now about a 50-50 chance. Others have suggested it's more like an 80% chance. But we anticipate that 2024 will be an even warmer year because we're going to be starting off with that El Nino event that's building now. That will peak towards the end of this year, and how big that is going to have a big impact on the following year's statistics. And so this story, these impacts are going to continue, and we're going to be seeing this pretty much throughout for the rest of this year and into next year. And so we could be seeing, as we've seen previously in 1987, 1988, 1997, and 1998, 2015, 2016 were both years in which you had a nascent El Nino, a record warm year that year, and then the next year was even warmer. And the impacts from those kinds of events are going to be continuing to make headlines across the world. The efforts that we're putting into seeing what's happening, understanding what's happening, and making predictions for what's happening, what will happen in the future through modeling of various kinds, including full Earth system models, is absolutely crucial to us understanding what's going to go on, and then to deal both with adapting to that, but also trying to prevent it from happening by informing decision makers about potential mitigation effects. Thank you.
Thank you, Gavin. Next, we will hear from Carlos del Castillo, Chief of the Ocean Ecology Laboratory at NASA's Goddard Space Flight Center.
So the oceans are also suffering heat waves. Actually, the oceans are running a fever. The waters around Florida are over 90 degrees Fahrenheit, which is extremely complicated for marine species like coral reefs, marine plants, and marine animals. And these issues with ocean temperature is not a problem that stays in the ocean. It affects everything else. Increases in ocean temperature causes increases in extreme weather events, torrential rains in coastal areas, but also inshore. They help fuel the intensity of hurricanes. They increase sea level with increases in coastal inundations, like the administrator mentioned. Miami Beach is getting flooded just because of high tides. Okay, this is completely unprecedented. And all this CO2 that we're putting into the atmosphere, which is causing the increase in temperature, a lot of it gets into the ocean, which acidifies the water. And this is not very good for a lot of marine species. We have increased the acidity of the ocean about 25% since the Industrial Revolution. And finally, we are seeing now that the biology of the ocean is changing, and we can say right now that global warming is contributing to changes in the amount of marine plants in the ocean. And why should we care? Well, these little marine plants, they are at the bottom of the food web. They produce about 50% of the oxygen that we are breathing. And of course, the ocean helps modulate the weather in the planet. The oceans offer us goods and services like transportation, food, medicine. And very important, about 40% of the world population lives around the coast. And in the US, if we take all the counties and parishes, and we make a hypothetical country, they will have the third largest GDP of the world, excluding the rest of the US and China. And these areas which are overpopulated, which have a strong economic influence, and are very important for the rest of the marine ecosystem, are also extremely susceptible to global warming. Now, fortunately, we have been looking at the ocean for a long time. We started making satellite measurements of sea surface temperatures in the 70s, I'm sorry. In the 90s, we started measuring sea surface height, and now with the SWOT mission, we are increasing our capabilities instruments. And since 1997, we started to do very good measurements of ocean biology. Many international partners have joined us in that fray, and pretty soon, in January of 2024, we will launch the PACE mission, which will continue these very important measurements, but also bring some unprecedented technical capabilities. So we are going to be able to see in great detail how the biology of the ocean works in general, but very important, how it's changing with respect to global warming. Of course, the PACE mission will also collect very good measurements about the atmosphere, aerosols, clouds, and after that, we're planning the GLIMMER mission, which will collect extremely good measurements of ocean biology in the coastal areas of the United States, the Caribbean, and South America. But the key thing is that aside for the satellite measurements, we also do measurements from airplanes, from boats. We have drones with laboratory work, modeling analysis. And the key is we take all this data to not only understand the ocean, but also to understand the Earth system. And we make this data available to all the community, and in particular to the policymakers, so they can do their job and make the correct decisions. Thank you.
Thank you. Up next, we have Wee Tran, Aeronautics Director at NASA's Ames Research Center.
Good afternoon. Can you hear me?
Yes.
Great, thank you. Good afternoon. My name is Wee Tran, and I'm Director of Aeronautics at NASA Ames Research Center. As you know, NASA Aeronautics has over a century of innovation in aviation, and we continue to develop green technology for next generation aircraft and sustainable energy for our aircraft propulsion. This innovation will ensure that the U.S. will be the leader in aviation. At the same time, we want to also working on technology that would address the impact of aviation on our climate. Last year, the Aeronautics Mission Directorate initiated a Sustainable Flight National Partnership. This initiative allows us to accelerate and making good progress on net zero aviation by 2050. One of the new X-plane called X66A that will be having new technology for sustainable aviation for single aisle. Another aspect of our effort is the electric propulsion powertrain demonstrator. In this activity, we are trying to take a look at the feasibility of fully electric power aircraft. In parallel, in airspace management, we're also looking at ways to reduce fuel burn and emission for our current commercial aviation today. As you know, as more aircraft in the air, flying people and goods around the globe, we will contribute to the climate change impact from aviation. So are we looking at new technology in airspace operation and aircraft technology, working with the FAA and airline partner to demonstrate that we can reduce fuel burn and emission for the aviation sector. Now, how does aeronautics helping in wildland fire mitigation? We did that by looking at new technologies such as unmanned aircraft and drone to begin looking at how we're going to help the emergency response system to be able to suppress the wildfire from the air. Last year, we started the new project called Advanced Capability for Emergency Response and Operation. This project, we will work with our federal government agency, industry, and other partners to come up with ways to suppress the wildfire on the air. And this would help us to be able to what we call the second shift, which means that once the wildfire fighter can go home or go back to their barrack, our unmanned and remotely operated aircraft with new air traffic management system would allow us to suppress the fire at night, which is when the wildfire is relatively calm. So we continue to do this on aeronautics, utilizing our aeronautics expertise and working with our industry to address the growing threat of the wildland fire and other climate disaster. Thank you.
Thank you, Lee. And up next, Tom Wagner, Associate Director for NASA Earth Action.
Hey, thank you very much. And I'll be brief because I know we want to get to questions. But Earth Action, or as we call it, Earth Science to Action, is our new strategic planning theme for the next few years at NASA for all of Earth Sciences. It has three basic components. Number one, we want to get the data out. You heard those earlier examples where we talked about helping farmers plan irrigation better, helping a city planner deal with sea level rise. There's even things we do like with the disaster response for the flooding in Vermont and Pennsylvania, where we do our best to help FEMA. And what we want to do is scale up those efforts so we can take NASA data and apply them to whatever challenge society brings. Personally, we're working a lot right now on climate change, but we're also interested in health and every other aspect of challenges facing humanity. The second big thing we want to do is get the information that's at the cutting edge research that we do with all of our satellites, models, and other things. And we want to bring that to the fore. A really good example of that, which the administrator mentioned earlier, is our Greenhouse Gas Center. What we're going to do is take the cutting edge measurements we have of methane release around the world. We're going to pull that together with the models and other data, and we're going to have a center so you can pinpoint where those greenhouse gases are coming from. I want to point out too, though, we're going to do that work in partnership with other agencies, right? Our big partners there for the Greenhouse Gas Center are the Environmental Protection Agency and also NOAA. But that brings me to the last component of our Earth to Action strategy, Earth Science to Action strategy, which is bottoms up. we really want to hear what society's needs are, and we have a real legacy of doing that with our applied sciences program. An example of that is University of Puerto Rico wanted more air quality forecasts, especially in light of more dust coming from Africa, and we were able to help there. And we're going to make every effort to identify even more of those needs and help society meet its challenges with all the great stuff coming out of our 25 missions orbiting the Earth right now. And with that, I'll kick it back to Catherine.
Thank you, Tom, and thank you all for that great information. For our in-person media, please join Kate Calvin and Karen St. Germain after this media briefing for a tour of our new Earth Information Center. We're ready for your questions, and to get into the question queue, please raise your hand on Teams. The audio live stream on nasa.gov/NASA Live will be available for playback. I will go in the order of hands raised, and I see Jeff Faust, you are first.
Good afternoon. This is Jeff Faust of Space News. Question, I know NASA requested a significant increase in Earth science funding in its 2024 budget proposal to support, among other things, climate science research. The appropriations bills currently working their way through the House and Senate would provide NASA with, at best, flat funding for Earth science. If that turns out to be the outcome of what NASA gets in 2024, how does that affect these climate science and other climate initiatives that you've been talking about?
Jeff, that's for me. We're going to have the least possible effect on any climate science. This is a huge priority for us. It's a huge priority for me personally, having lived through this as the senator from Florida and seeing my state being completely challenged every day, every hurricane season. And it is a huge priority for Joe Biden as president, but I saw him as senator be at the forefront on the changes that are occurring in our Earth, and we're getting hotter. Now, let me just point out, there's going to be less money. There's going to be less money because a huge bipartisan agreement with an overwhelming bipartisan vote prevented the country from going into financial default and going over a financial cliff. As a result of that, part of that agreement was to basically go back for fiscal year 24, which starts in just a few months, October the 1st, to go back to essentially no more than the 23 appropriations of which we are in right now, fiscal year 2023. The House bill has brought NASA out with a fairly close to the 2023 appropriations. The Senate bill, about 386 million less. The compromise is going to be somewhere in between. There are many twists and turns before this final agreement. But in the process, you're going to see yours truly that is going to be trying to protect this climate science. And so I hope that gives you some reassurance, Jeff.
Great. We will move on to the media in the room. Seth Bornstein. Where's yours?
Seth Bornstein for AP for both. It's one question, but for both Gavin and Dr. Calvin. In terms of the summer records and temperatures and extremes we're seeing, Gavin, you said it was no surprise, but some of these things are, other scientists have said, are a little more off the chart than expected. Which of these are more surprising to you and disturbing to you? And is it arriving earlier than you expected, some of the levels of these extremes?
Yeah, maybe I'll start and then I'll turn to Gavin. So the last 9 years have been the warmest since modern record keeping began. We're on a trend of increasing temperatures, and with those increasing temperatures, we are seeing more impacts, and that's something that we as scientists have known for a while. Some of the research back into greenhouse gases and the effect go back to laboratory experiments in the 1850s, and over time, we've broadened our understanding of how the planet works and what to expect. I think what's sometimes different for people is when you actually experience it in your neighborhood where you live. And I think that's what we're seeing now, is that people are feeling these impacts. But we've seen these trends and rises in temperature for a while, and we know what's driving it. And I'll turn to Gavin now for his insight.
Yeah, thanks, Seth. That's a great question. So things like, longest continuous over 110-degree temperatures in Phoenix. Shocking, but not really surprising. Breaking records in Rome and Spain and China, shocking, but not surprising. I think the departure in the North Atlantic sea surface temperatures, that raises an eyebrow for me. That's an interesting phenomena that seems to have happened very quickly, and is related to perhaps changes in aerosols, perhaps extreme NAO behavior, perhaps differences in kind of dust feedback. So we were talking about that earlier with the Sahara. All of those things may be playing a role in that specific instance, and I think that's certainly a situation to watch and to dig in a little bit deeper once we have more data and the time to really analyze what's going on. But we've been predicting that the rainfall is going to get more intense. We've been predicting that goes roughly 7 to 10% more intense rain as you warm the planet by about a degree. That's what we have done, and that is happening. And so, it's not even the things that are unprecedented are not surprising. Now, we have to be a little bit careful when we're talking about like truly unprecedented situations, like the 40-degree temperature in the UK last year, and and similar, quite frankly, off the charts warming in China last week. It's very hard to tell from the instrumental record whether these are now something that's going to happen, once every 10 years, or whether it's still locally like a 1 in 1,000 year or 1 in 10,000 year kind of event. And our models, we can't evaluate their estimates of these kinds of really, really rare extremes because they still are rare. That's why they're making the headlines. If the model says it's a 1 in 100 chance or a 1 in 10,000 year chance, it's very difficult to say whether the models are correct or not. You really need to build our understanding looking at the whole kind of extreme tail of the temperatures and the rainfalls, and we haven't really got enough data to evaluate those. And so when people say, "Oh, the models, might not have predicted this," it's not quite clear what the standard is that people are holding the models to, because we have a real lack of time and information to really assess these things. But the trends that we're seeing over larger aggregated areas in rainfall intensity, in heat wave occurrence, in heat wave intensity, all of those things are playing out pretty much as the models have been predicting for years.
And Seth, you'll be able to see a lot of this real time displayed visually as it's happening on the Earth Information Center.
Great, thank you all. I will turn the next question over to Haley Smith.
Hi, thanks for doing this. This is Haley Smith with the LA Times. I was hoping you could talk a little bit about artificial intelligence and what role it might play in some of the projects you described today, and what role you see it playing in the future as you continue to track and respond to climate change.
Go ahead, Gavin.
Hi. Yeah, that's another great question. And so NASA is at the forefront of funding research into machine learning and digital twin technologies for climate and earth science. We're seeing work that is being done to use artificial intelligence to help tune models, to calibrate them better to the real world. We're seeing efforts to improve process-based understanding that we can then, include those in the models and do it in hopefully a faster and more accurate way. We're using machine learning to downscale impacts so that the models that have a relatively coarse resolution, so that we can use that the information that we have from the observational record to try and make more accurate projections at the local scale. We're not. This is me speaking personally. We're not going to suddenly see machine learning tell us what's going to happen to climate. So we're not going to just be able to look at the world, put it through something like ChatGPT or DeepMind, and then it's suddenly going to be able to tell us what climate is going to do in the future. Our information about the future, we don't have enough data from different kinds of climates to be able to constrain in a purely data-driven mode what the climate change is going to be. But we are using machine learning as much as we can in a kind of physics-guided way so that it still kind of maintains what we know from fundamental first principles to make better predictions. And so we will be, I think, increasingly seeing efforts to use machine learning to do that. Where we have, really very large amounts of data and relatively well-constrained physical problems, then we can use machine learning to inform those things. And so we can be using the process-based data from the satellites. We can be using the high-resolution models to inform the coarser resolution models. We can be looking at more complex and involved models that perhaps include chemistry and aerosols, and we can use those to inform the models that don't have that. And I think you're going to be seeing a lot more efforts along those lines in perhaps in the months to come. We're actually running a session at AGU on machine learning for climate and weather, and so I'd welcome you to that in San Francisco in December.
I'll just briefly add 2 key points. This is Karen St. Germain. So we are, as Gavin discussed in the context of climate, we are seeing AI and machine learning come through across all of our science disciplines as another tool that people use to go after science questions of all sorts. That's going to become increasingly impactful because just within the next 2 years, between SWOT and NISAR, we will have doubled the entirety of the NASA Earth Science data holdings. So to manage to extract meaning from ever increasing volumes of data, these are going to become increasingly important tools. That's first point. Second point is we are also seeing a tremendous amount of sophistication and excitement in our early career scientists around AI and machine learning, and this is a key part of our efforts to bring new people into our field and help us tackle the challenges that society is seeing.
Thank you both. Up next, we have Darna Noor.
Hi, everyone. Darna Noor from The Guardian here. Thanks so much for holding this. Last month, Copernicus, the European Union's Earth observation arm, said that the first few days of June breached that 1.5 degrees Celsius increase compared with pre-industrial times, and said that it was probably the first time that ever happened since industrialization. Just wondering what you all think about the potential that could occur again, and what the sort of record heat that we're seeing right now could mean for another breach of that 1.5 degree mark.
Yeah, maybe I'll start. This is Kate Calvin, then I'll turn to Gavin for to add in some extra. The point I want to make is, when we talk about 1.5 degrees Celsius, often when scientists talk about it or when you hear about it in sort of the policy arena, we're talking about global warming over long term, so 20-year averages. And so a single day or a month or even a year exceeding 1.5 degrees Celsius doesn't mean we've reached that level. But I will turn to Gavin if he wants to add anything on whether we've experienced that before. You are muted.
Sorry. I'm not actually sure that statement from Copernicus is true. I think in January and February of 2016, we exceeded 1.5 degrees above the pre-industrial for, I think, February and March of that year for the whole month. So that's not unprecedented. I think the focus that we have kind of gone into in recent months, focused on the daily data. That's a relatively new thing, but it's more a function of the availability of that very nice website that the University of Maine has put together than it is of something fundamentally different that's going on. As Kate mentioned, 1.5 on a daily basis or even a monthly basis is I don't think unprecedented, and I don't think in and of itself cause for concern. Obviously, as we get warmer, we're going to go through more and more days, more and more months, and eventually years that do exceed that temperature. And as we get warmer, we are going to see more impacts. But nothing fundamental changes at 1.5, right? So 1.49 or 1.51, we're not going to be able to distinguish the difference, but we know that impacts increase much faster than the linear change in the global mean, and so any long-term change that gets us closer to that or past that is going to have an outsized impact on things like extreme rain, heat waves, fire, sea level, and the like.
Great, thank you. Are there any other questions? We have time for one more. Questions in the room? All righty, well, this has been a great discussion of climate work in the wake of record high temperatures. That's going to wrap things up for us today. A list of our climate resources is available on our home site, nasa.gov. And please, whenever you're in DC, visit our new Earth Information Center. It's open Mondays through Fridays from 8:30 a.m. to 5:30 p.m. And our panelists are available for interviews. And if you have any follow-up questions, please send them to me at catherine.a.roloff@nasa.gov, and we'll get back to you as soon as possible. Have a good evening.